Hello everyone, my name is Naveen Kumar and I'll be presenting on the topic of my project, which is development of predictive model using NLP techniques for mass media. But first, let us have a look at a little bit of an introduction. Everybody consumes news via newspapers or apps that you have in your mobile phones. Mass media has made the whole world a smaller place. Because of internet and a lot of new technology such as the smartphone and the app store, we now have news at the tip of our fingers. Anyone can just connect to the internet and get to know immediately in detail about what is happening, where, when, and how. But the problem with that is it is a hotbed of misinformation, propaganda, information war, and many more. So the thing is, the authors are trying to manage and influence the opinions of their readers. They might be doing this knowingly or unknowingly. Knowingly, they might have ideological biases. They might want to introduce fake news. There might be lobbying factors involved. Unknowingly, they might try to distance themselves from their opinions, but fail like everybody else. So this is the problem, right? Today's news, as mentioned in the previous sections, are filled with opinions, biases, and conflicting sentiments. This makes it hard for a reader, a person who just wants to know about the event, and form their own opinions and not be swayed by the author's opinions and sentiments. This is exactly what we tackle with this project. So let us have a look at the existing systems that, for example, InShort, an India-built application that serves up all sorts of news from all providers in under 60 words. This is great for consuming news at a very quick pace and getting to know what is happening. All the summary is prepared in hand by human editors. And on the other end, we have Feedly or any other aggregating service where you can put in or whatever input you want and it'll aggregate all the news and deliver is to build a system that would aggregate news articles, analyze them to predict the sentiment, extract the key phrases, and create a summary, and present all this news to the reader. So this is exactly the proposed system. The first part would be an aggregator that crawls through all the websites. Second would be the processor module that extracts the sentiment and key phrases and the summary. The third one is the presenter, which is comprised of web interface and the API. So this is the activity diagram. When a user wants to know about certain events, the user can just input whatever terms that these inputs are then received by the web server, which then sends it to the respective modules. It first predicts the sentiment and then extracts the summary and then finally extracts the key phrases. This is all put together and returned to the user as output. Data flow inside the system is very simple. Once it accepts the input search terms, it first searches in the database to check whether or not the same articles that are being scraped exist in the database. If so, it just gets those content and displays it to the user. If not, if the data doesn't already exist in the database, it then processes the article to get the sentiment, then gets the summary, and then finally gets the key phrases. And then it adds everything to the database and then finally displays the output. This is the overall system architecture. The core of this whole is a web application, a web service built using Flask, the popular micro framework for building web applications. So the main two output methods are the app routes and the API endpoints. The app routes would be the things that serve up all the HTML pages, and the API endpoints is for CLI and programmatic access. The processor system comprises of the article aggregator, which crawls the websites of all the news providers and gets all the links and the articles. Sentiment extracts the sentiment, key key phrase extractor extracts the key phrases from the article, and the article summarizes the article to two sentences, which is a limitation we have imposed on our own. It can be extended to n number of sentences as the summary. All this data is stored in a Postgres database, which has been defined by the database models using object-oriented methods that is facilitated by Flask SQL Alchemy, a library. This whole web application is served to the internet via an Apache 2 server on port 80. So let's have a look at one of our simple algorithms to summarize the article. First, it extracts all sentences from the input article. It removes all unnecessary stuff. It removes certain abbreviations and ambiguities. It then splits the sentences by dividing it in locations where there are periods. The second one is to extract all the words. White spaces are where we split each word. We then remove punctuation marks and words that are technically similar and convert plural words to singular. And then we assign a score to each word. It is based on the frequency in the text. Common words are obviously ignored. The fourth step is to assign a score to each sentence. The sentence score is a sum of all the scores of its component words and is divided by the total number of words, which gives us the score of each and every sentence. All this is put together, and the top n number of sentences is given as a summary. So when I said that we take two sentences, so the n equals 2, and we give the top two sentences as a summary. Now, the implementation part, as told in the system architecture, Flask is the microframework that we use for all web-related implementations, which is a Python framework. It is connected to a Postgres database and it serves the internet by the Apache HTTP server. Let's have a look at the demo. The web server is already running at localhost as shown right here. I've run a couple of tests before, so that's the output that you see there. But let's have a fresh look at some of the things. This is what you get. So let's say you want to know about something about Modi and maybe something in relation to Karnataka. So now all you have to do is put these search terms inside this box and hit search. You can see the processing happening over here in the server. It received everything and processed it and then returned it immediately. Well, that was quick. The reason why it was this quick is because I had already searched for it once before and the data was present in our database. That's why I just scanned the database, returned all the articles. As you can see right here, this summary is quite big because we've limited it to a huge number where n is something in the order of 5 or 10. That is why the summary over here is huge. But other than that, the keywords are 10, and we have all the other information, the sentiment. Well, here is one article where the sentiment here is negative. This is one more. So let us go back and have a look at something that may not be in the database. So let's just search for Modi. So what is happening right now? So it is contacting the Hindu. As you can see, it's extracting all these things. Now it's processing the key phrase for the first one, key phrase for the second one, and so on. This is the output in the server side, which is obviously not visible to any end user. It's just for debugging purposes and for the purposes of this video only. So once all that stuff is done, yeah, this is done, and now we can go back and see that we have. So this is a common article that we can see from Modi and Karnataka. See, this is a different article. This did not exist in the other one. So didn't the rest of the stuff. This one too. This is the different one, and so is this one. So the search results are basically uh, from the Hindu website. So whatever it returns as the search results, we take it and process it. So for example, Modi, this is what it returns, right? Yeah, we have it right here. This is the first article. Second one is All Eyes on Pranab. That's right here. So it searches for all the articles that might have been present in the database, which are returned on the top, and then it processes the ones that aren't in the database and returns it at the bottom. So let us have a look at the CLI access. With the API, there's a lot more functionality provided. So one of the functionality that the API offers is to have filters. For example, we can have this filter saying, you want to have results that have key phrases Congress government and was written by a specific author. So you can just hit this and then it will return this. The feature here is that it scans its own database. The server scans its own database to find articles with the following key phrase and the author filter, and then returns that. So maybe there are other filters, right? We could have author and date, and we have multiple articles presented from the database that are written by one author at the same date. And this is the case wherein the user fails to provide any of the any of the input filters and just tests out the API, in which case it has to be handled. So this is the error that the server throws out, saying, you haven't provided any of the input, and this is what this is what the data that we've received, and that is why we are throwing this error. This system can be port to multiple websites, all the other websites that cover news. The other one is to add language support, which is going to be very difficult considering there are a lot of NLP happening inside the extraction of summary and sentiment. Other than that, it would be much more suitable in our case to use Elasticsearch instead of a conventional database because of all the searching that is happening right now. The other one would be to implement a proper topic modeling and try to find links between the articles so that you can in a way predict where one article was a series of articles were written about one particular story and could track how it occurred. That ends the demo. Thank you very much. Have a great